Hello, this is a documentary of 15 kilowatts lithium battery installations and equally the 10 kVA inverter connections. Here we have 300 watt solar panel, 12 pieces of them that we are trying to use with our hybrid inverter in order to power the system. Over there you see the roof assessments with our ray mount already available, and the processes of taking this panel to the roof is very crucial, and we take it step by step by first arranging the ways to do that. It can be done automatically and it can equally be done manually. In the manual installation, all we need is to use rope. Being under the roof, all you need to do is to tie the panel, then ensure that somebody is on top of the roof to receive the panel. As you can see, the processes, they are very simple, strategic, and equally required skills, not power. Over time, a lot of people think solar installation requires much power. You see how we're able to take all the panels to the roof, and the connection is so neat, how excellent the job is. By positioning it right and running the underneath connections, making the job professional. No one notices how this is done if not the way I review the secret now. I'm sure you are gaining value in this video. Kindly click like, subscribe, and equally be notified when our video comes up again. Like I said, this is our connections. After the connections, we send the cable down to where, or the workstation where the inverter and the batteries are. Seeing this enables you to know that this is important, and when we get there, there are things we are going to look out for. One is the place properly connected. When I mean the connections, there are things we need to do before the connections can hold and run the finishing. One of those things is we look out for the pipe. If the house is well installed with the conduit pipe, if not, we deploy the use of trunking pipe. Like in this video, you can see that we deploy the use of trunking pipe. Why is trunking pipe necessary and important in solar installation? Perhaps your plan of using conduit pipe, and all of a sudden the bricklayer or anyone working there closed all the pipe and you couldn't use your fisher over them. The easiest way to ensure that your connection is done properly and neat is to deploy the use of trunking pipe. When you do that, you should be able to lay your cable. After the trunking pipe, there are other things you can use. We have equally cable rails, cable trays that you can lay it, but for the purpose of excellence and also ensuring that everything is covered, you need to use trunking pipe. After that, you lay down your cables. As you can see, we are laying down all our cables here, and after the cable laying, you need to find out the sizes of cable that is needed per time. In the battery connection, we have sizes of cable that is needed, like the 25 mm cable, we have 35 mm. All of them should be flex. Why do we use flex cable in solar installations? That will be our next topic, and I believe if you watch this video to the end and click in my next video, you will see why flex cable is adopted in the solar installation. Looking at this too, you can equally see that this is our inverter, the 10 kVA inverter. The 10 kVA inverter has the ability to handle the load of ACs, the fridge, the fans, the TV, the lighting points, and every other thing in the house. Then we have the inputs, which is for the NEPA or the grid. Then we have the output. Then we have the battery terminal, where you can terminate your battery. Then we have the solar input, that is the PV side, where you can connect your solar panel. Now that all these connections are done, what is needed again. First, you position your battery the way you want it to be, then measure the cables to ensure that it does not stop or demand joining of cable, because it is important that the cables will run all through in order not to experience what we call current or voltage losses. So for you to maintain this, you can do that and do what we call co-testing. Here our inverter is on. You can test the inverter without connecting it to the load, and equally test it without feeding in the input except the panel. Looking at this, our inverter is on. The 220 volt or 230 volt you are seeing is the output, whereas the 117 volt you are seeing is the voltage from the panel. So the panel will charge it effectively roughly 3 to 8 hours at the first charge before you can turn it into use. Then this is the battery. You have to see the specifications first and equally check the parameters after your connection to ensure that you met the proper connections before powering it to the house. Looking at this, you can see my BSM is available. You see my battery management system, that is the BMS, is available. That's why I can access to see the battery voltage and also the percentage of charge. You see the current rating of the battery. The battery is 300 amps hour. Then if you have done this, the next thing you look out for is to check the capacity of load that this can handle, so you won't overload it. Now, checking those processes, you can see the specification and equally come to my inverter. The inverter is on. I love the way this is being done. We have MPPT charge controller, which has the ability to charge the battery without grid. That is why it is called hybrid. Now we power it and everything is working. Watch out and see. Thank you.